Look around your home. You likely have a smartphone, a laptop, and a smart TV. Dozens of screens pulling down data. But the internet arrives at the building through a single physical wire running from the street into a box in your living room. That box is your modem. Its job is to bring the outside connection indoors. It receives data from your internet service provider and hands it off. But the modem itself lacks the internal logic to share that one connection with multiple devices at once. If every device in your house attempted to talk directly to the modem at the same time, the data packets would collide and crash. It would be a digital traffic jam that stops all communication. The router was engineered to solve this physical bottleneck. It sits between the modem and your devices to manage the flow of information. Because internet service providers only sell you one public connection, the router is the only reason you can connect 10 different devices to the web through that single wire. Before it touches the global internet, the router organizes the house by creating a local area network, or LAN. This animated diagram shows the router sitting at the center of a closed loop of every device in the building. The router takes attendance using a system called DHCP. As each phone or laptop joins the network, the router deals out a unique, temporary numerical tag to that specific hardware. This tag is called a private IP address. It might look like 192.168.1.5. These addresses are strictly local, meaning they only exist within the internal network of your house. By giving every device a unique local address, the router prevents internal data requests from getting mixed up. However, there is a conflict. The global internet does not recognize these local tags. This technical source image shows how ISP routers handle data packets containing private source addresses. They are immediately blocked and discarded. To bridge this gap, the router performs a real-time translation service called NAT, or Network Address Translation. As shown here, NAT intercepts outgoing requests from your local devices. It strips away the private IP and restamps the packet with the router's single, globally recognized public IP address. In this wider view, you can see the result. Multiple computers are now surfing the web simultaneously, using just one public IP. NAT allows the entire household to share the same outside connection. NAT serves as the bypass for the single-wire bottleneck, hiding the complexity of your internal network behind one unified public address. If every device uses the same public IP to send data, how does the router know which device should receive the information when it returns? This diagram shows the use of ports. The router attaches a temporary tracking number to every outgoing packet. This number identifies a specific ongoing conversation between a device and a server. When data returns, the router checks its routing table, an internal ledger that matches port numbers back to the private IP that started the request. Following the green arrow, the router can see exactly which computer on the LAN requested that specific packet. This record-keeping ensures that a video requesting data flows flawlessly from the street, through the modem, and out to the correct screens. The router processes these translations and port checks thousands of times every second. This device is a high-speed traffic director. It provides the logistics required to connect an entire household of hardware through one physical cable.